Hello and welcome to this video. In this video, we want to look at how we find the relative molecular masses of these three different examples that we have. So what is relative molecular mass? Well, relative molecular mass is the sum total of relative atomic masses of the atoms present in a molecule. Now, what symbol is used to show that we are calculating relative molecular mass? The symbol Mr. is used to denote that we are finding the relative molecular mass of a molecule. So we have an example of water. So we are basically finding the Mr. of water. Now, every time you have been asked to calculate or to find the relative molecular mass of a molecule, you cannot find this without using the periodic table. This is because the relative atomic mass of every element is found on the periodic table. And it's to this reason, in this video, I have the periodic table to help me to solve. So now, when you are calculating the relative molecular mass, you need to take account of each and every atom present in the molecule. So let's look at oxygen. How many atoms of oxygen do we have? We have one atom of oxygen. Now, what is the relative atomic mass of oxygen on the periodic table? I'm having 16 as the relative atomic mass. Then let's go to hydrogen. How many hydrogens do I have? I have 2 hydrogen atoms. And what is the relative atomic mass for hydrogen? It is 1. Then I find the total of these multiplying numbers. So what is 1 times 16? I'm getting 16. What is 2 times 1? I'm getting 2. So we find the total of this, it will give us 18. So 18 becomes the Mr. of water. Next example, we want to look at the Mr. of CHCl3. So let's go to the periodic table. We see, according to the molecule that we have 3 atoms of chlorine. So say 3 multiplied by, what is the relative atomic mass of chlorine? It is 35.5. So 3 multiplied by 35.5, it gives us 106.5. Then we come to hydrogen. We have 1 atom of hydrogen. What is the relative atomic mass of hydrogen? It is 1. 1 times 1, we get 1. Then we come to carbon. We have 1 atom of carbon multiplied by the relative atomic mass of carbon is 12. So we are saying 12 there, we have 1 there. So we are adding 106.5 plus 1 plus 12. It should give you 119.5. So this becomes the Mr. of this molecule. The third example, we want to find the relative molecular mass of aluminium. It has 2, then open bracket, SO4, cross bracket 3. So we have 3 atoms there, that is aluminium, sulfur, and oxygen. Now, how do we find the relative molecular mass of this? Let's start with oxygen. You'll notice that sulfur and oxygen is in the brackets. So this simply means this 3 number is affecting the 2 atoms. So already we have 4 atoms of oxygen. So we'll multiply 4 and 3, which will give us 12. So 4 times 3, it will give us 12. Then we get the relative atomic mass of oxygen. So when we look at the relative atomic mass of oxygen is 16. And when we multiply 12 times 16, it gives us 192. Then we come to the next one, which is sulfur. So sulfur, because of these 3, and sulfur is in the bracket, we have 3 atoms of sulfur. We go on the periodic table. What is the relative atomic mass of sulfur? It is 32. So we are multiplying 32 and 3. It gives us 96. Then we come to aluminium. So how many atoms of aluminium do we have? We have 2 atoms of aluminium. Then what is the relative atomic mass of aluminium? It is 27. 27 times 2 gives us 54. So after this, you add the 3 numbers. So when we add 192, 96, and 54, we should get 342. So this becomes the mixture of this molecule. Don't forget, this video was brought to you by Zolova Consultants.